All right, guys. So we're going to start average rate of change over given intervals. I know that you guys have a lot of Algebra 1 knowledge about this. So therefore, this should go smoothly, right? All right. So we're going to start off with defining average rate of change. It is a really deep concept. You're going to be using this in Algebra 2, pre-cal, calculus, and it just gets a little more expanded each course, okay? But let's start with a simple definition. Average rate of change is the slope of a line connecting 2 points on a graph. Do y'all remember that from Algebra 1? It's just the slope of the line connecting 2 points on a graph. Your rise over run, okay? It is very easy to find the average rate of change graphically, but algebraically, we can use a formula, okay? The formal way of writing our formula is written in function notation. Notice how it says f of b minus f of a divided by b minus a. Okay, your Algebra 1 teacher should have previewed this just a little bit in function notation for you. So now it's our turn to dive a little deeper, okay? What this is saying is that you're on an interval from A to B. And order matters when you're finding the average rate of change. Does that make sense? It's going to matter because it's telling you where you start and where you end, okay? Your f of B represents where you ended. Your f of A represents where you started, okay? Now, referencing back to our good old Algebra 1, that's when we had y2 minus y1 over x2 minus x1. And your interval was from x1 to x2, okay? So there is the correlation. It's the same, but remember how I started off with saying it's a deep concept, and we're just going to keep expanding on it, okay? All right. So we're going to do a quick little review of graphically. So graphically, we have here, we have, what's the shape of this graph called? A parabola. We have a parabola. We have a quadratic function here. Okay. In Algebra 1, you spend a lot of time just looking at linear functions, right? Well, linear functions aren't the only functions that have average rate of change. That's because average rate of change is just connecting the 2 points, okay, on a graph. Our interval here is from -3 to 1. I know that because right here it says average rate of change over -3 to 1. So when I'm using the graph, I'm identifying those points and connecting them on a line. After we identify those points in Algebra 1, what did you do then? What did you calculate? The rise over run. You don't say. So you're going to find the rise over run. How much did I rise? I went up 8. I ran 4. So therefore, what was the average rate of change for the 8 over 4, which is 2, right? Makes sense? Okay, now we're going to reiterate how to do that algebraically, because you're going to always have the graph of the function. No, you're not. Okay, so without the graph of the function here, we have x squared plus 4x minus 1. So if I'm looking at x squared plus 4x minus 1, and the interval that it wants me to look at is from -3 to 1, okay, that's the interval we're looking at. We're going to first start off with by finding our ending. Your f of b is where do you end? Okay. F of b is where did you end? So it says over the interval. Okay. So where did we end? We end at 1. So we're going to substitute in, that means our b equals 1, and we're going to substitute that in. So we have 1 squared plus 4 times 1 minus 1. That gives us 1 plus 4 minus 1, which equals 4. Yeah? All right, now we're going to do this. Your f of a represents where you start. So where did we start? At -3. So we're going to substitute in -3. So we have -3 squared plus 4 times -3 minus 1. That's going to give me 9 minus 12 minus 1. And that equals -4. Okay. And now you're just substituting everything in. So what did we get for f of b? 4. What did we get for f of a?
4.
What did we substitute in for b? What did we substitute in for A?
-4.
-3. Okay, a negative times a negative makes a positive. So this is actually 4 plus 4, which is a negative times a negative is actually a positive, which makes this 4. So lo and behold, oh my gosh, 2/1. So our average rate of change is 2. Do we see how that works? Okay, the graph is going to be like your safety net. If you have the graph, that's what it's there for. So what I'm going to challenge you to do is you're going to do the algebraic. Don't do the graph first, but on our next example at your table, you're going to algebraically find the average rate of change on the interval from -2 to 2. So from -2 to 2, you're finding the average rate of change, but I want you to do it algebraically first and then check yourselves graphically. All right? So you're going to do it algebraically first, then check yourself graphically. This is not a time to nap. It's not a time to check your phone. It's a time to actually try and practice the material. Go. All right, let's see what we did. So remember, your f of b is where did you end, right? So my ending value of my interval is what? 2. So I'm substituting in 2, and that's going to be my b value, right? So everywhere that there's an x, it's going to become a 2. So we have 2 cubed minus 4.5 times 2 plus 1. That's going to give me 8 minus 9 plus 1, which equals 0. Okay. Your f of a is where do you start on the interval? And where did we start? At -2. So f of -2 is going to be -2 is going to be our a. So we're plugging in -2 cubed minus 4.5 times -2 plus 1. That's going to give us -8 plus 9 plus 1, which equals 2. How are we doing? Good. So your f of b was 0. F of a was 2. And we plugged in, what was our b? What was our a? And a negative times a negative makes a positive. So we have -2/4, which equals -1/2. How did we do? Okay. And then you should have checked yourself graphically. So checking yourself graphically, notice when I'm doing the rise over run, I went down 2. So that is a negative. And then I went to the right 4. So that is a positive. And I still end up with -2/4, which equals -1/2. Yes?
Yeah.
Average rate of change of any function. We're feeling it? Yeah? Okay, good. All right, we're going to do another one. This is going to be, yep, another one on your own. It is a different formatted quadratic. This quadratic is in vertex form. Does it matter that it's not in standard form?
Yeah.
No, it does not. It does not. Our interval is what? What's the interval? 0 to 4. All right, go again. I'll give you another 3 minutes. Algebraically, then graph. All right, so here we go. Did it matter that this wasn't in standard form? No. The process is still the same. So my b is where do I end? And where did I end at? 4. So when I plug in f of 4, I get -1/2, 4 minus 2 squared plus 4. This is evaluating. That means you're going to be using PEMDAS. So remember PEMDAS? Okay, PEMDAS says I deal with what first? Parentheses. So that gives me -1/2 times 2 squared plus 4. After parentheses, what do I deal with?
Exponent.
Exponent. So that gives me -1/2 times 4 plus 4. Then I deal with multiplication or division. Multiplication. What is half of 4?
-2.
It's going to make -2 plus 4. And now I can add, and that gives me 2. Do we see how we use PEMDAS? Okay. Then we're going to do it again. Where did I start? 0. F of 0 equals. So we have -1/2. 0 minus 2 squared plus 4. And again, we're going through PEMDAS. And this is going to end up being 2 also. F of B, we got 2. F of A, we got 2. B minus A is, and does it matter what's in the denominator? No, because as long as my numerator is 0, my result is going to be 0. Does that make sense looking at our graph? Yes, I did not increase or decrease. I am constant. I stayed 0. And that's why it's 0, okay? Remember, the average rate of change of 0 doesn't mean that it's constant. It means it's just no increase or decrease on that interval, right? All right. So instead of constant, I should say continuous. Yes. All right. So on Monday, we're going to do the bottom, and then the rest of the period, you have an assignment to do using these notes. Got it? All right. Good day, guys. Good day.